Binary basics. The easiest path to understanding zeros and ones. Decimal to binary. Now that you have learned how to convert binary to decimal, it is time to flip the process and go in the other direction. This lesson is all about converting from decimal to binary, and we will build on everything you have already learned thus far. You will see how the same place value chart that helped you read binary numbers can now help you build them. To do this, we will be using the subtraction method, which works especially well when you have a place value chart to guide you. Using this method, we will move vertically from the top down and horizontally from left to right, one column at a time, until your decimal number is fully converted into a binary value. When converting from decimal to binary, your job is to break the decimal number down using the largest possible binary place value first. To keep things simple, we will work with an 8-bit structure. This means we will be using 8 fixed place values, one for each binary digit or bit. Using the subtraction method, we will start at the top left of the chart with our largest place value, 128. From here, we will work our way across from left to right, one column at a time. By the end, your chart will be filled in with a full binary number, 8 digits long. So are you ready to give the subtraction method a try? Great! Let's jump right in and walk through a full example together using the decimal number 181. To create our 8-bit binary number, we will work from the largest binary place value down to the smallest, moving one column at a time from left to right. The place values we will use are the same ones we have seen before, which are 128, 64, 32, 16, 8, 4, 2, and 1. Now you may have noticed that each place value in our chart is preceded by a negative sign. That is to serve as a reminder that we will be subtracting the place values as we go. Now for the step-by-step process. We start with the current decimal number and ask, is the current decimal amount greater than or equal to the current place value? If the answer is yes, we write down a 1 for that column and subtract the place value from the current amount. If the answer is no, we write down a 0 and move on without subtracting. That new current amount becomes our working number as we compare it against the next place value. So let's start. We begin with decimal value 181, and our first place value is 128. Can 128 fit into 181? Yes, it can. So we record a 1 in the 128 column at the bottom and subtract 128 from 181. That leaves us with 53. Now we check 64. Can 64 fit into 53? No, it's too large. So we record a 0 in that column and keep our current decimal amount at 53. Next is 32. Can 32 fit into 53? Yes, it can. Therefore, we place a 1, subtract 32, and that brings our current amount down to 21. Now we check 16. Can 16 fit into 21? Yes, it can. Again, we record a 1, subtract 16, and now we're working with 5. Next up is 8. Can 8 fit into 5? Nope, too big. So we place a 0 and keep the current amount at 5. Now we check 4. Can 4 fit into 5? Yes, it does. We add a 1, subtract 4 from our current amount, and we're left with 1. Moving on to the 2's place. Can 2 fit into 1? Nope, too large. So we drop in a 0, and 1 remains as our current value. Finally, we reach the 1's place. Can 1 fit into 1? Yes, it fits perfectly. We place a final 1 to finish off our binary number. Subtract the place value, and that brings our current amount to 0. And ending up with 0 is a good thing. End up with anything but 0 and you probably made a mistake. Most likely with a comparison check or a subtraction calculation. So, when we put it all together, the binary number for 181 is 101101001. Each digit in that binary number came from a simple comparison and subtraction, one column at a time, until we worked our way through all 8 bits. That's the power of the subtraction method. It is clear, predictable, and easy to repeat once you get the hang of it. This subtraction method works with any binary number. And once you get used to comparing your current value with place values, you will start to recognize common patterns and convert even faster. But no matter how large or small your binary number is, the process should always start by finding the largest place value that will fit into your current decimal value. After that, just move one place value at a time to the right until you reach the 1's place. Thank you for watching. Subscribe for more great content.